presentation, entitled Research Traveling the Electric Road System, concerns the development of an innovative research project focused on the decarbonization of transportation with the dynamic wireless power transfer system. Before I begin to describe the various topics, let me expound an inspirational quote. Greta Thunberg, in one of her denunciation events on climate change, said, "The world is waking up and change is coming, whether you like it or not." Nowadays, climate change is clearly visible and has caused disastrous effects, in some cases irreversible. So either we adapt and change our habits, or we will be more and more enslaved by the climate change effects. In the project that will be illustrated, it will deal with the enhancement of transport from the point of view of eco-sustainability. The eco-sustainability definition should be interpreted as the set of approach to ensure that we leave a healthy planet to our children and grandchildren. That is to say, we don't affect the resource of future generations with our contemporary activities. The presentation is divided in 7 sections, starting with a brief introduction and then explaining the system and technology that govern the development project, and then allowed for the identification of the individual variables. The identified variables were the protagonists for the first preliminary phase, the experimental phase, in small-scale laboratory. Then we will move on the large-scale design and construction phase, or rather full-scale, in however limited extension. Next, I will describe the operating technology and show the stage that the project has currently reached. Then, finally, we will move on the conclusion. As already introduced, climate change is one of the most widely discussed issues. This is cause for concern in scientists about the consequences it will have on nature, humans and animals. One of the main factors of pollution, which has led to the deterioration of the quality of the environment, is the production of and emission of CO2. The main defendants have been assessed to be transportation systems operated by combustion engine and by industrial production chain. For a number of years, the most sustainable alternative identified to deal with pollution caused by the movement of vehicles on the road has been the vehicle operating with an electrical power engine. It is a very good solution, except that with the current method used for charging, there will over time be an increased demand for electricity to charge vehicles. The electric vehicles on the road today are not entirely environmentally friendly. A large amount of rare raw materials are used to build their battery. With the change in the fleet from combustion to electric engine, will not be able to guarantee response to all users. Another problem remains the disposal of these at the end of their useful life. In addition, with the current methodology, vehicles need special parking areas that they use for the time and needed to recharge. This subtracts urban space and conditions the users in his movements, both in terms of the recharging time and the autonomy it provides. 3 types of vehicle engine operations were compared in this slide. The DWPT system and the plug-in system are both technology in which the vehicle has an electric motor. The difference is made by the type of battery and especially its charging. In the DWPT system, the charging of the vehicle battery takes place during its direction travel and without any contact, using the physical principle of induction. The plug-in system, on the other hand, is what we already use. It required times and place to stop. Obviously, the direct benefit is travel range, recovery of time and urban house now taken away. Instead, the comparison with combustion vehicle is definitely the reduction in emission from both vehicle operation and full production. Other disadvantage of the plug-in system is the lack of approval of the charging device. The device and plug-in footprint vary by vehicle model and country. In addition, the power discontinuity of the power grids in the territory do not allow at each site to achieve the same charging speed. Another observation is that depending on the type of vehicle, a specific power is required, and therefore the user is conditioned to plan not only when his long stops will occur, but also where to locate in the territory. At the time when the demand for electricity will grow due to the increased use of electric vehicles by users, the DWPT system is uniquely capable of meeting the energy needs. The DWPT system is able to adapt to any type of vehicle, so it fully solves the homologation problem and eliminates the problem of time and space that the vehicle needs for charging. The DWPT system is what we consider as hidden infrastructure. We don't see it as it is covered by the pavement. Its operation is based on the physical principle of the magnetic oscillating field. In fact, we can understand it by taking the example of our rechargeable smartphone with wireless system battery charger. How does it work? Both a recharging device, the source, in our case the DWPT system, and the device which must be loaded, possess within them electromagnetic coils. Specifically, the DWPT system is composed of energy converters and passive elements, including the magnetic device that communicates with the receiving device, which is precisely the coil contained in the vehicle battery. To summarize quickly, there is a source of electricity that powers the plant. This energy goes through transformers and current converters, and up to here we are in the electrical cabin. The current passes through the management unit composed of inverters and then travels to the electromagnetic coils that are below the road pavement. The key point becomes the passage of the vehicle over the road. The vehicle contains within its battery and electromagnetic coil that communicated with the DWPT charging system. Briefly, these are the steps by which charging takes place following this innovative methodology. This slide is intended to convey that this system is currently being studied for vehicles involving road transport, but may be extendable to any class of transport, such as even trains. The problem will then become finding alternative and environmentally sustainable form of energy to be able to sustain demand. Before moving on, the construction and the test circuit will be the product of this presentation. Some basic laboratory experimentation steps were followed. This made it possible to select the materials to field it on the circuit. For reason of trade secrecy on the partners who supply the bitumen additives, it will not be possible to go into much detail. However, a combination of bitumen with innovative additives have been studied to slow down the evaporation caused by the electromagnetic field on the chemical bonds of the bitumen. The study of bitumen was initially of a chemical type, focused on the spectra of the chemical compounds of bitumen were obtained with the use of Fourier transform infrared spectroscopy. This analysis will be repeated on the bitumen extracted from the core, which will be taken from the circuit every 4 months. Rheological analysis of bitumen was carried out at the stage of unaged bitumen, aged RTFOT and PAV method. Then the fundamental rheological parameters of the complex modulus on the phase angle were obtained. Subsequently, given a granulometric curve established by the technical specification, The mixtures are made and square-shaped bituminous asphalt plates with a size of 50 centimeters are created. The plates consist of the wear layer and binder. The plates were used to reproduce the conditions that the following undergo when subject to the activity of the electromagnetic field. An electromagnetic field is simulated in the laboratory, and the response is evaluated by applying sensors in several points. Then the materials for the realization of the circuit were selected. Once the experimental part was over, the practical part began, which will follow the workflow indicated by this diagram. The first phase has been completed and concerned the construction of a circuit with a shape similar to an asphalt ring, with a length of 1050 meters and powered by electricity with a power of 1 megawatt. The second stage, which started at the end of June 2022, concerned the application of the DWPT system to various types of vehicle. In future, the implementation of the data obtained from vehicle traffic will be integrated into point 234. The circuit was built on the land owned by the Bobemi Motorway Company. The location is in the northern Italy, near Chiari Est, in the province of Brescia. This slide shows the circuit layout and the particular of the cross-section of the circuit. The ring has different colors because as you walk around it you encounter 7 different types of paving. The table shows the characteristics of the 7 types of flooring that make up the circuit. In this slide on the left, there is a photograph showing a model of one of the 7 row sections on the circuit. This photograph illustrates how it was made concrete that protects the electromagnetic coils responsible for induction, and the trench concrete where the coils are laid out. On the right, on the other hand, you can see a photograph showing the 7 cores of pavement with their characterizing layer types. During the testing phase, it will be cores like this that will be extracted. Mechanical tests will be performed on these cores in order to derive the trend of the mechanical parameters of the material subjected to the electromagnetic flux. The goal will be to identify and optimize the interaction of road materials with the electromagnetic flux. I will now show you how this system is installed in the road pavement and what operations are required. Starting from the left to the right, you can see that there are 2 beams that are excavated. One is needed for the allocation of the electromagnetic coil strip, while the narrower and deeper beam is where the cable and coil operating device are placed. The cable will then find connection in the cabin where they receive the electrical energy, are ready transformed and converted from the grid. This slide shows the detail of coil installation and arrangement. First, the coils are placed to form a continuous strip. Partly, the connection elements to the power supply electrical system are placed with their cables. Once these installation steps are completed, the protective casing is filled, on which the road infrastructure will rest. When construction and testing phases of proper operation are completed, a Fiat 500 car and an Iveco bus, like prototype vehicles, begin to circulate. Since the coil strip is located on the outermost lane of the loop, the vehicles during the testing phase will always circulate on the outermost loop. On the board of each vehicle are mounted connection devices that demonstrate what is the charging capacity of the vehicle and what is the amount of charging they receive from the DWPT system. The testing phase with vehicles has only started since the end of June 2022, so today there are still no results that can be announced. Currently, however, thanks to the connection system installed in the vehicles, we already have an estimate of the consumption and earnings that the vehicle have by circulating supported by the DWPT system. The table shows by average speed sustained by the vehicle the energy consumed and stored for 1 kilometer of road, that is for about 1 lap of the circuit. On the left you will find a zoom of what lies beneath the road pavement, that is what we early christened as high infrastructure look like. On the right, on the other hand, is a time frame of the activities already completed, those in progress and those planned for the future phases. To conclude, I present the next goals, which are focused on the quality and resilience of the asphalt mix to electromagnetic flux, and the optimization of all its mechanical characteristics in the perspective of aging. As always, the extension of the service life of a road pavement depends on the ability of the material to withstand the boundary conditions to which they are subjected. But in this case, in addition, it will be particularly necessary to focus on the interaction with the electromagnetic field. I leave you with a video in the hope of having exposed the content as clearly as possible. Obviously, this project is the result of the collaboration of various partners and professionals. Here you can find my contacts, and thank you for your attention.